So, Paul, do you and Venkat know each other?
No, I don't know
No.
that, yeah.
Why don't you guys introduce yourself? Paul, why don't you introduce yourself first?
I'm co-founder and head of design for a distributed ledger technology startup, which is called L4S. It's sort of ledger for securities. We're predominantly based in financial services, although we have interest in supply chain. And that seems to be the area we may go to first because it's got less regulatory hurdles. We've raised seed funding and developed a capabilities demo. But I had a very sort of different approach to what was the design approach. And we have what we call a near real time, high capacity and scalable distributed ledger transaction and accounting protocol. And it really came out of when I looked at the original designs 4 or 5 years ago. I saw the potential and I saw that they worked, but I saw issues with scalability and capacity, throughput, and latency, as well as functionality and ease of adoption. So my design was geared to, resolving those issues, and so I've been, proselytizing on that for that time while we've been developing our solution.
Oh, I could learn a lot from you then.
That's why we do these things, Venkat.
No, I've tried to. I mean, I've learned a lot involved with the GBA and meeting different people, and I try to give back. And Gerard knows I produce videos on LinkedIn, and I'm going to say it today. The introduction, like a lot of people think I'm anti-blockchain. I'm like, no, I'm just like pro positive solutions. I said, but I have to call out the limitations where I see them,
So that would be a positive or a area that we both will agree is a pro positive solutions. Although I do speak pro blockchain, I do. So maybe a little bit of introduction to myself, right? I've been doing blockchain solutions for about 4 years now. Mm-hmm. Started off building my own Hyperledger network and Ethereum token for myself just to learn. Mm-hmm. My specialty is system integration. I've been doing system integration applications for over 25 years. I have a focus. My master's degree was focused on system integration, actually. So when blockchain came into existence, where was I? So when I at least learned about blockchain. So yeah. I've been, since then, I've been kind of building on blockchain solutions, designing, architecting. I have a patent in my name on a highly scalable data sharing platform that was built for sharing military intelligence. Oh, wow. So I'm building a healthcare solution based on that patent now. Okay. And supply chain is of interest for me. I work for CGI. I lead blockchain practice for CGI US, and supply chain is of interest for me. So you and I need to chat. I have some thoughts on manufacturing and supply chain. So
yeah, my career started as a manufacturing engineer, and then I transferred to banking operations, and so I've been a sort of more of a process guy all my life in terms of process design, process management, or process design for new products. Yeah. So that's I've got some appreciation of technology as an engineer. We all were forced to code in machine code and then BASIC, then Fortran, and so I've got the appreciation, but that's from the supply chain side, it's how do we synchronize the physical and the digital, and then also coming from the financial side, we're it's not a stretch for us to incorporate a payment solution, and that we think the delay, if apart from better information and data and control, the biggest complaint on supply chain is I didn't get paid for 6 months. So it's like
I have a trade financing solution CGI has a trade financing solution that we have blockchain enabled. And that's the discussion I wanted to have with you.
Yeah.
So,
all right.
Excellent. Well, So I'm
Hey,
just letting people,
Gerard.
yeah, Mark.
Yeah, I never received a cancellation for the management team meeting. You might want to send that out real quick.
Oh, son, sacre blue.
Maybe it's in
Thanks.
the other Zoom meeting that Gerard has.
Yes.
Well, it's in the other Zoom meeting for exactly this reason.
Hi, guys.
Hey, do you go by Dimitri or Mitsu?
Both are fine.
All right.
Okay. Hello, both are fine.
Can I ask you, Kagdila?
Of course you can, as in any other language, like, I don't know, try something else as well.
All right, guys, I'm going to step away for just a second. So normally what we do, we never start on time, right? Because it always takes time for folks to come on board. So we first 5-10 minutes is generally just small talk and introductions. I'm going to step away from the phone for just a moment. And then by all means, feel free, the folks on the call, to introduce yourselves. This, again, for most of you who are, or for many of you that may not have been on this is really intended to be a discussion. So, all right, I'll be back in just a sec.
Dimitri, one difference I understood with the name Dimitri is, as opposed to Dimitris, which is a Greek name. Dimitri is more Russian, Ukrainian.
Yeah.
Okay.
Hey,
Good.
hey, listen, I'm hosting a meeting.
I can start and end a conversation in Russian. That's all I can do.
You just do a round robin with folks.
Yeah.
And then,
What you're saying is you have a scalability.
I'm on.
Gerard need to learn how to switch off his microphone.
As long as he doesn't do anything inappropriate.
Yeah, I'll try. I tried to do that.
Never know.
And it didn't work. I'll try again.
Okay, either that or just let people know that we'll have to cancel for today.
Okay. Yeah, I'll try to get on. If it won't let me on, I'll figure something out.
Okay. Bye.
All right, bye.
Lily, that's a wonderful background.
Thank you.
Lily is in. Lily, you're in Boston, right?
Yeah, I'm in Providence actually.
Rhode
Oh,
Island.
Providence. Okay, so close.
Yeah.
So Lily, why don't you introduce yourself to some of the fine folks on. I'm going to have the panelists all introduce themselves to everybody around 12:05, 12:10. But
Okay.
why don't we have some of the other folks let us know who you are so we can engage in conversation that's meaningful.
Thank you. Yeah, so my name is Lily, and I just get involved with blockchain last year. So I'm very new, I'm a beginner. I'm here to learn. So I'm sitting on board of the Boston Blockchain Association to drive up the membership. I met Gerard, during, was introduced by Chris. So yeah, we are trying to, we are in conversation of building a partnership so we can promote the blockchain technology, building an ecosystem, so cross city.
Wow.
Yeah, nice meeting you all. I'm glad. I was very happy when Gerard sent the invitation. Thank you for the invitation.
Well, the folks up there, the Boston Blockchain Association, are just doing. You're just doing great work, and you got a great group of people. Who are some of the folks that are associated with your association?
You mean the companies or? Who?
Yeah, companies. People.
Yes. So we have a Hedera Hashgraph, Consensus, Algram, and a few others, and Boston Fed, very important. Yeah,
so we're working with them to they've sort of looked to see what we've done over the past on a couple of years, and we're just trying to share share the goodwill and help out any way that we can.
Mm-hmm.
So, hey, we've got Philip. I thought I saw you on here. Philip, you want to introduce yourself and tell folks a little bit about, I don't see you right now. Are you on somewhere? Philip. Oh, there you are. Yeah, you want to introduce yourself? Oh, you're on mute. You're still on mute. All right, we can't hear you, Philip. All right. Yep. And he's on his way back. All right. So we got Venkat, we got Paul, we got Dimitri, we got Ron. Excellent.
Do you hear me now?
Perfectly.
Okay, thank you. So my name is Philippe. I'm actually French. I'm a CEO and co-founder of a startup in France around blockchain, actually. So our company has created a tool which is a blockchain enabling technology, actually, to connect the legacy IT systems with all kind of blockchains. So it's a tool to industrialize blockchain in all IT solutions.
Excellent, excellent. Beverly, would you like to introduce yourself? Just as we're saying good morning, good afternoon to most people.
Good afternoon, everyone. My name is Beverly Lynn. I've been in the blockchain space. Actually, I've known about it since 2008, but I just returned back to the States not too long ago for being based in South Korea for the past 10 years. I'm doing missions work as well as university. I'm interested in distributed ledgers, specifically looking at how universities, in particular Asian countries, predominantly South Korea, where they have an overarching university, but different schools, for example, a business school, a school focused on politics, but they're all separated, and the administration of all of those different units can definitely use a distributed ledger. So I'm interested in listening to this conversation.
And Beverly is going to be playing a role with us to help us implement leadership and culture throughout our organization. So it's been really great getting to know her. Renika, welcome. Would you like to introduce yourself and say a few words? I generally have folks just kind of introduce themselves the first 5 or 10 minutes of these events.
Yeah, absolutely. Thank you so much, as always, Jared. My name is Renika with Advanta IRA. Professionally, I work in the self-directed retirement space. So, helping investors use qualified retirement funds to invest in alternative assets. Personally, I'm relatively new to the blockchain technology. I'm just, trying to learn as much as I can, network with like-minded investors and individuals, and just immerse myself in the space. So I'm just, happy to be a part and trying to absorb as much as I can, so I can, move with this fourth industrial revolution that's blockchain.
Excellent, excellent. And I think I've shared my screen. Can you guys see my screen?
Yes.
Yep. Okay, perfect. Good, good, good. Mark, you want to introduce yourself and let folks know a little bit about what's going on in the technology space at GBA?
Sure. So I'm Mark Wasser, Chief Technical Officer of the GBA. I guess what I'm supposed to talk about currently is the government business blockchain platform. Basically, we're trying to build a platform that is a coalition of any other blockchain that's willing to connect to us, so that we can provide services that are available from any of them to everyone who, or at least any government agency who wishes to connect to us. We've got a cross-blockchain token that serves so that we can buy services and sell services across the platform. And this is also the platform where the GBA reward token is located.
I wake up 6 o'clock in the morning. All
right. Excellent. Yeah, so that's going to be just a really powerful platform. We're in talks, right? In fact, we've got a call later today with the Texas Blockchain Council. We're talking to some folks in the European Union and Slovenia, and different folks around the world. Because if we can really sort of support interoperability between blockchains and then create different ecosystems, then it's essentially going to be just phenomenal. So, and Mark has been doing tireless work. If you're interested in in that project. Mark, do you want to put your email address in the chat?
And
by the way,
were you
this
the one who posted that startup can raise funds even during a pandemic?
okay. All right. So I'm going to put everybody on mute for just a moment. I'm allowing participants to unmute themselves. So if you have something that you'd like to share, and I'm going to give folks just another minute or two to do that, then please do. Just go and unmute yourself and then share what you want. And then I'm going to introduce the panelists in a second. Wendy Charles, would you like to take yourself off mute and just tell them a little bit about what's going on with Burst IQ and Research Foundry?
Oh, happy to do so. And thank you for the invitation. This is Wendy Charles, Chief Scientific Officer at Burst IQ, and I've been a member of the GBA healthcare group for 2 years, and it's such a noble cause. So if you're not already a member, I encourage you to join. At Burst IQ, we created a humanitarian initiative that we called Research Foundry, where we host data sets and allow individuals and organizations to join the platform for free if they are developing a solution, and we can provide additional scientific support if they are also trying to address COVID-19. So if anyone would like to learn more about that opportunity, please go to www.researchfoundry.com.
Awesome. And we got some incredible stuff that the healthcare working group is doing. They're launching a digital ethics framework, and they're about to start working on a new project called the Healthcare Delivery Blockchain Platform. So there's just all kinds of stuff.
Really important. Thank you for emphasizing that.
I'm so excited about all the work that you guys are doing. I wish I had time to tell you about all the different projects that we have going on at GBA. I was mentioning right before a lot of you came on board, we're in the process right now of creating an assessment methodology for blockchain solutions. It won't be long in the future where governments have to make decisions between different blockchain solutions. So we're creating an assessment method similar to CMMI or ISO 9000. It's a blockchain maturity model, and so that's one of the things that we're working on. And so what it does, it provides a framework for acquisition professionals to look at blockchain solutions to determine, how mature they are in terms of their governance model, their sustainability, different things like that, their security. So it's going to be really exciting. Their scalability. So I'm going to be taking a lot of notes today. We got just so many cool projects going on. Let me go ahead and tell you a little bit about our panelists today. I'm so absolutely excited about the fact that we got Venkat, we got Dimitri, we got Venkat from CGI, and I wanted to include Venkat because he's got a lot of experience in working with governments. And then we've got Paul. Paul's company is building a really great scalable solution, and Paul is he's a constructive critic of blockchain technology, and so he's done a lot of work really identifying what the holes are, what the vulnerabilities are, what the challenges are, and then looking for solutions. So his criticism and solutions are going to be great. And then we got some, actually we have a couple folks from TON. Dimitri is going to be our primary panelist. And TON is a scalable solution. I'll let them tell you a little bit more about it, but they have a huge global community of developers and they're working on lots of solutions. Their community is part of the GBA community, and we're just totally excited to have them on board. I'm going to ask each of them to introduce themselves so that they can tell you a little bit more specifically about their background and what they're working on. Then I'm going to ask each of them to make an opening statement, and they can share their screens. I'll end up asking them a couple questions just because I'm insanely curious, and then after that I'll open it up to everybody. Once we open it up to everybody, please feel free to just raise your hand. I'll acknowledge you, and then you can ask your question. You can put questions in the chat, and I'll also try to get to it. But I find that when people can actually talk and engage directly, it's just a lot more interesting. So with that, Venkat, why don't you go first, followed by Paul, followed by Dimitri. Just an introduction, and then you can do your opening statements. You'll have to unmute yourself.
Give me yeah, I was just about to say, give me a moment. Then I was like, okay, I had to unmute myself. Thanks, Gerard. So you want me to give a quick overview of who I am, and then we'll go at a later time to more details? Is that how you want me to do it? Okay. All right. So
and normally just to kind of give you a framework, kind of where you've been, how you got in this space, and what you're excited about.
Yeah. Perfect. Thank you. I was just telling Paul earlier before you all joined. I've been in the IT industry for about 28 years or so. And I have my specialty in my master's degree in computer science was actually in system integration. I built a distributed directory server for my master's thesis on Sun platforms. That's kind of how I got introduced to distributed applications and system integration in general. But growing up, have built, deployed, ran, and managed multiple enterprise applications with tens of thousands of users and customers over the years. Been with the US federal government for 11 years, ran IT operations. So I've seen the gamut. Got introduced to blockchain about 4 years ago when the US government first, GSA first issued an RFI for a blockchain application. And I kind of quickly picked up to speed and learned about blockchain. Built my own small Hyperledger 0.6 version application, and then built my own token on the Ethereum. That's kind of how I learned how it works internally. And since then, started kind of climbing up and being architecting and designing blockchain solutions in addition to going on the writing white papers, going on speaker market and things like that. Off late, about a year and a half ago, we built a very highly scalable blockchain-based solution for the military, US military industry, out of which we have a patent that CGI has, and I'm one of the named patent holders for it. Basically a scalable data sharing platform. And I'm also using that patent, we're building a scalable data sharing platform on the healthcare space as well, which I'm in the middle of designing right now. So my background comes from actually running and deploying scalable solutions, and of course, designing and building and managing and mentoring the development team to build these solutions. 4 years in blockchain. So happy to share my thoughts and knowledge. Thanks, Jared, back to you.
Sure. Paul?
Hi. Hi, everyone. I'm Paul Downing. First of all, thank you, Gerard, for this opportunity. And again, I'll emphasize, how great the work you do and the GBA and everything you've achieved is incredible. And I'm happy to be a part of it, and I'm glad I can sort of give back a little.
Paul, I have to tell you something. There's a saying in our house: behind every successful man is a surprise mother-in-law.
Oh, God. There we go. All right, that's true for me too. I started my career as actually a manufacturing engineer. My degree's in engineering. I then transitioned to a sort of management program in the UK, was banking operations, and I spent a good time in operations and service, and then moved to sort of product management and then innovation and design across many of the sort of large institutional banks and brokers. I've also consulted independently. My last role, I was working on internalizing trades. We had the idea of, settling in trades within a larger institution where they have both sides of the transaction, and that was going to get us to T0. And that was around about the time blockchain was taking off, as well as the fact that I happened to transfer to a boutique consultancy. So they asked me to look into it. And as my wife has said, the planets aligned. My father was involved in encryption with radio, so I knew about that sort of technology. Although I don't usually admit it too much in public, although I'm doing it very proudly now. I have a lay interest in like number theory and meta mathematics, and I've read the papers of Gödel and Turing. So when you deal with blockchain and you're confronted with modular mash and hashing or elliptic curve encryption, I don't claim to be an expert, but I'm not intimidated in the, I understand the principles. So that got me to the nice bits. But as a process guy and a design guy around process control, I looked at what was out there, and it's about 4 or 5 years ago, and said, great, I now know what the potential is. I know why everyone's excited about it. But I saw some limitations within the performance and functionality and ease of adoption, and I'll come to those points when we start off. But and really, I thought those would be the challenges that people would be looking to solve for. But there's a lot of access to downloadable or open source software solutions, and that's where people were going. But I kind of locked myself in the room and sort of said, okay, how would I solve for these 10 challenges? And came up with a different type of design. Initially we weren't a fintech startup, so we were trying to propose it to banks and brokers and anybody who'd listen. And then that led to us actually saying, okay, we've got to start a venture here. And so we seed funded, and we've got now a capabilities demo, which is going to help us raise Series A funding. And we hope to have a production version for our targeted clients. And also in the meantime, we also, offer advisory and due diligence services in this space, because the one thing I'm happy about is that I got into blockchain 5 years ago. With all the progression and evolution and noise, it's a pretty steep hill to climb for any new people coming in. So I've recorded videos on LinkedIn where I'm trying to sort of outline some of the points and issues for educational purposes, as well as just to help people understand them. So I'm looking forward to this discussion. I will caveat it with some of the points I'm going to make, that some people think, and Gerard was saying a constructive criticism. I am not anti-blockchain. I'm very big believer in the potential. But Gerard said it best. He'd seen some of my videos and said, really, I didn't like the message too much. And then I realized you were speaking truth to the issues and actually trying to provide solutions. So it's going to be an interesting discussion.
Excellent. Thank you so much. Dimitri, would you like to introduce yourself? And then after that, in fact, why don't you introduce yourself and then go ahead and make your opening statement, and then we'll circle back around to Paul and to Venkat.
Okay. All right.
And
so,
what time is it there?
Like 7:30.
Oh, 7:30. Okay, not bad.
Not bad. Not bad. Not bad at all. So yeah. So my name is Mitya Goroshevsky. I'm CTO of Ton Labs, and Ton Labs is a core developer of free Ton blockchain, which we have started development about 2.5 years ago, when the Telegram wanted to build a blockchain, and Dr. Nikolai Durov has come up with this design for his blockchain, which is like a scalable, some say infinitely scalable blockchain with a very fast finality. And back then, about 3 years ago, like there was nothing in the vicinity even to compete with this kind of design. So it was very interesting to me, and I started to build this team, like the co-founder of I'm a co-founder of Ton Labs, and then we started to build this team of engineers to build a solutions on top of Ton, and basically to provide an infrastructure for a Ton blockchain. And of course, we did a lot of things, like we are doing compilers, and we were implementing another implementation of the full node, and the protocol itself, and many other things. And then, of course, the SEC had a problem with Telegram raising some money, and Telegram had to stop producing this blockchain. And the community has started instead using the open source code from Telegram, but also, of course, the Ton Labs code, which was handy, and in this respect. And we have launched the free Ton blockchain starting from 7th of May. It's a totally community-driven project. It's unique. It has a unique model of token distribution because we didn't have any ICO. We didn't sell a single token. All the tokens are distributed to the community through contests. So it's all meritocratic system. You contribute to the community, and the community pays you back in a contest-like fashion. And that's how tokens have been distributed so far. We have distributed, like the community have distributed around 20 million of these tokens already. There are great partnerships which has been announced again with the community, like World Chess, for example, which is the largest chess platform with the exclusive relationship with FIDE. So all the ratings and everything will be moved to Triton blockchain, and all the chess ratings of the official FIDE chess ratings and stuff like that. We can read more about that. And of course, one of the reasons why it's all possible is because Triton is actually scalable blockchain. Now, me personally, I've got into blockchain from the very beginning of Bitcoin. Like, don't remember the year exactly, but it was a year or two after Satoshi has launched the Bitcoin. The reason I was there is because we have from 2004, and again, yeah, also you can look up my names in the patent directory. We had a serverless peer-to-peer architecture. So it was a DHT-based storage kind of project, which we have been developing, and it wasn't very successful, this one, because we were like just ahead of time, so there was no market for that yet. But as part of this research that we were doing and the implementation that we were doing, we obviously looked at everything peer-to-peer and everything, like consensus or whatever. And then, of course, the Satoshi paper popped up. So and since then, I was really like interested in that. But it was very limited platform, obviously, payments and money, it's all fine. It was fascinated engineering-wise in terms of like the idea, but the implementation quite straightforward. And you could hardly build on top of this as a computing platform. And then the Ethereum came. Like actually beforehand, it was like several other things, which obviously, were also interesting. But Ethereum really broke that, for me in terms of introducing the smart contracts. And from there, I was like really interested to build stuff on top of that. I was involved in some Ethereum based projects before the Ton. And before all that, I was in Israel, where I have started I was basically picked up the voice over IP idea on the very beginning, because I was listening to some Good Morning Israel program on the TV. And it was a Vocaltech who introduced the first voice over IP software, which they invented actually in the public internet. And I was so fascinated from this, I said, I want to do that. Just said on the spot, I want to do that. I want to build a global network of operated just voice over IP instead of all this telecommunication bullshit. And we've been in Israel for like, just a couple of years. And the call from Israel to Russia cost like, I don't know, $5-6 something per minute. So obviously people could not call back. And for that, I mean, it was really appealing to me. I said, this is something I want to solve. This is a problem I want to solve. And I started a company called Delta 3. It's later on went on NASDAQ, reached a crazy 1.5 billion or something valuation. It was one of the first voice over IP service providers, and it was built on top of the technological platform that we have developed on for actually being able to transmit this voice. Later on, I started another company in voice over IP space, which was later on acquired by Terion Communication, which was a cable modem provider back then. What we did was enabled cable modems with voice over IP. So we were one of the participants in the DOCSIS 2.0 standards for voice over IP transmission. So that's how I got into the space. That's my background. In terms of the opening statement, I think part of that I already did. If we're talking about scalability, I can share, I think, my one slide.
Sure.
Let me try. So.
And then Paul and Venkat, if you guys want to share any slides or anything like that, why don't you just prep them?
Yeah. So something like that. I don't know how to show that here, but anyway. So this one really, I just wanted to concentrate on this. If we're talking about scalability, I think we need to define what that means. I mean, why do we need to scale the blockchain at all? What is scalability? Kind of what parameters do we want to, measure this scalability by? And of course, there are several things that have been proposed that it's picking up like last 2 years, I think. And we can see that with the DeFi movement, why it picks up. And that's part of the obviously answers to the question, why do we need to scale? Like if we have a meaningfully large project, even in the normal IT world, we wouldn't be even calling that large project actually. Like DeFi, what it has like 10,000 users, maybe a little more, 50,000, I don't know. Because the Ethereum platform is not scalable at all, the cost of transaction reached some $7-8 in the peak of DeFi. And also we can remember, of course, CryptoKitties, which was also a big project in terms of blockchain, but very small, normal, let's say, IT, which kind of stalled the Ethereum network completely when it went viral. So that's the reason, I think, the prime reason why do we need to scale it. But in terms of definition of scalability, here the answer varies a lot. I'm sure if you will ask like all the panelists now, you will get how many panels do we have? That's how many different answers I think you will have. And I can also, of course, like provide my answer to that, and let's see how others answering that. And my answer would be that it's a throughput, and the throughput we measure in latency and the amount of transactions we can execute, right? But latency, for me, is one of the most important parameters, which sometimes just get completely forgotten or purposely forgotten, I don't know. So when, for example, Ethereum 2.0, the whole architecture to solve scalability problem is built around the kind of transactions, how many transactions you can actually execute. But it doesn't really answer the question of how many transactions you can actually execute in the second or at certain time, right? Yeah, you can execute this transaction, but it will take you 6, 7, 8, 10 seconds. So the latency will be big, like it will be very large. If you are opening your application right now, Facebook application, for example, and try to reload your feed, what would you say if that reload feed would take you 10 seconds? I think you won't use it at all. So if we want a solution in the blockchain space, which can actually be used by the user and by the end user, and that's, I think, what was the requirement that Nikolai Durov also put in front of himself when he started to develop this architecture, and what we are improving upon is not only how many transactions you can execute, how many people you can serve, but also how fast you can serve them. So I think for me, this is the metric that I want to see in scalability. And of course, Freeton is the platform which is has an answer to that and answers to that with a certain architecture and solution. But there are, of course, other competing solutions to that. And there can be, I think, classified in like maybe 3 categories. One category would be what Ethereum is trying to do now frantically, because they, not only because the Ethereum 2.0 is kind of delaying a lot, but because also it doesn't provide the answer. So they're coming up with a lot of L2 solutions, and that means creating additional layer on top of the blockchain, whatever the blockchain is, and trying to delegate there the actual transactions. It could be like and L2 solutions, they are very different. They exist a long time. There are different designs. I don't want to go into that, but that's one of the kind of possible solutions. But there are a lot of challenges and problems with that, with L2. And again, we can expand later if you want what the problems are. Second approach is just to make one chain and make it reasonably fast and with the reasonably good throughput. And these are solutions like Algorand, solutions like Solana. These are the interesting projects, really interesting projects in that domain. And Solana is beating everyone up right now, big time. It has the largest throughput and with the really small latency. It's a great design. We love Anatoly Yakovenko's work and his team. It's really brilliant design. It's a genius design, I would say even. But of course, it has a problem. As any other, engineering is the science of compromises. So it scales up to the point, and particularly when you do computation. So if you want your platform not just transmit again the money very fast, but also to execute certain code, then you will start to have problems, because it's like comparing a single thread. Think about blockchain as a processor, and I always, we like to think of a blockchain as a processor. If you think about blockchain as a processor, it's very apparent. Like you can have a very, very fast single-threaded, computer and a processor, and you can execute very fast. It would be very easy also to develop on that. It's not complicated in terms of the architecture. So it has a lot of advantages. If you can build it really fast, like Solana did, you can do fine. But in the end, if you want to scale more, the multi-threaded processor would beat you in terms of architecture, in terms of capacity of executing different programs. And since it's not one program that we are executing all the time, we're actually executing arbitrary amount of programs with arbitrary amount of calculations, more or less. The multi-threaded approach seems, the better one. And we have, of course, several of this called sharded. It's not exactly always correct to call this blockchain sharding blockchains, because not always you shard the data. And once you don't shard the data, it's not technically called sharding anymore. But again, I don't want to go very deep into that discussion. And the best solutions currently being developed or released are Near protocol by Alex Kidanov and his team, and very interesting approach, pretty close to Ton, but not precisely. There is Polkadot, a very different kind of blockchain, because it's a blockchain of blockchains. It's actually created to provide a platform for different developers to actually create their own blockchains and kind of connect it to under the same protocol to this meta blockchain. So I think these two are the most interesting in the sharding, and of course Ethereum 2.0, which is also interesting, but it's interesting mostly because of its decentralization properties. But again, we can talk about that later if you want. And Freeton. So I think that's my opening statement. Sorry for being detailed, long.
That's great. Mitcha, thank you so much. That's awesome. Paul, would you like to make any kind of opening statement, opening remarks before we throw it over to questions?
Sure. Thank you. I'll probably, I was nodding in agreement with some of Dimitri's comments and shaking my head at some other points. Looking at scalability, the obvious one is the performance. The less obvious ones are functionality and ease of adoption. So I'd like to sort of go through those and then talk a little bit of how some of them can be resolved. In terms of performance, the continuous requirement of keeping the entire ledger in active memory, which is sort of a throwback to the Bitcoin model, is obviously ultimately unsustainable. And so that's the sort of memory scalability. Consensus as a process, the votes to be counted expand exponentially as they increase, because you've got two factors, number of nodes and number of votes that increase with participation. And so you've got two numbers that are increasing multiplied together, and that's why that's issue. So those are the two scalability issues. A lot of the solutions involve multi-step, multi-person processes, which also create areas of control, single points of risk, and ultimately, from a production engineering perspective, create capacity and bottlenecks and other things. So that process, and as Dimitri pointed out, there's also a natural latency in these processes. Like, it's not so much that I'm throwing, a ton of transactions into the network. It's like, when do I find out it's accepted? And there's, as these solutions have uncertainty or control issues, you have soft forks. So, Bitcoin, you're supposed to wait for 6 blocks. With other solutions, you get some sense of consensus, but you've still got to wait to see, and things can change. And in the financing world, latency causes a problem, because if we move to a same-day market with money, we have to have money available. And the only way that's available is if we pre-fund transactions, or we have intraday financing. And you can only achieve intraday financing with near real-time settlement. You need to be able to borrow and lend and finance positions in the moment. You can't sort of say, I'll lend it to you, and it may be 5 minutes, it might be an hour, I'm not sure. Just depends how people vote and whether they mine my my transaction or not. So with that arbitrary latency, it creates uncertainty. So there's 2 scalability issues: the capacity throughput and the latency. As far as functionality, it comes down to, because the memory issue, and I'll give you one of the solutions here, is to break up the memory, you have to do what all the banks and brokers do today, which is you have a starting balance, a transaction, and an ending balance. That allows you, your bank statement is actually, hard copy printed, is an immutable record. You can't go back and erase a credit of 100 and make it 1,000. It doesn't change your bank balance. But you've archived the periods because you've separated transactions from balances. And this is one of the throwbacks to Bitcoin as well, that the UXTO model is recording balance changes, not transactions, and certainly not debits and credits. Because of that, your transaction exists in the block it was created, rather than as a carried forward active balance, which is what happens in today's ledgers. So being able to separate transactions and balances, we can create periods. Because we've got periods, we can archive the history, but we can also post future dated transactions. And we can create new types of assets, which are called payables and receivables. So, and that's the whole thing behind loans. Up until now, I see a lot of people contain those type of transactions in smart contracts, but they're algorithms, and you can't accrue interest off an algorithm. You need to actually post an accrual to a ledger as a future dated transaction. And that comes back to a real fundamental thing, that we're ultimately dealing with distributed ledgers, and ledgers require double entry accounting. Otherwise, you can't run a trial balance, you can't balance monitor the ledger, you really can't reconcile it internally, and you can't reconcile to it externally. Now, people will say, oh, but I run an algorithm against it. And I'm like, that's fine, but for audit perspectives, you've got to take the entire ledger, your algorithm, and your output, and show that you reconcile to your downstream general ledger or other financial reports. The problem is you have to keep that entire history, a copy of it every day. Now, people will argue, well, no, it's immutable and it just expands every day. And I go back to the DAO hack on Ethereum, where they actually were able to go back in time and change the records. So if you'd have kept those Ethereum records from the period the hack happened to when they hit the Wayback Machine, you actually, all your audit records would be out of whack. So this is a real issue in terms of continuously expanding active memory and requirements. And then the last thing is sort of ease of adoption. You're not going to digitize assets in a day. So you need to be able to settle through your network, from network to network, as well as network to legacy systems. You also usually have a requirement in financial services to transition in positions or transition them out. And all these crypto assets exist in their own networks, but that's where they're perfected, and that's only where they exist, except in digital form in another network. So the idea of being able to actually move assets between networks is a sort of a concept that has to be considered. And the reason I bring up functionality and ease of adoption is because you can have the highest performing distributed ledger, but if it doesn't perform the functions, or it isn't easy to adopt, it's not going to be bought anyway. So those are the kind of things we have to take into consideration. Now, as far as getting to near real-time processing, the way it's achieved, and people are iterating towards this, but you really need, if you look at the TCP, the Internet Protocol, it's an independent process that still remains interlinked within the network. That's the key thing. We went from LAN and WAN technology, which always had the central controller. Yeah, so you had interdependent processing that was interlinked, but you were dependent on the central processor. What you really need is independent processing that somehow still remains interlinked. So it's parallel processing, and then you can obviate the need for the consensus or the competition because it can retain its integrity. And there is actually research based on this in terms of what they call conflict-free replicated data types. And it just says if the data has certain properties, you can replicate it. You don't know when you're consistent, but you know it is consistent. And we've added a layer of completeness as well, so you know when you're consistent. But that's the fundamental theory that sort of backs what our design is, and in terms of being able to process in parallel independently while remaining interlinked. And it sounds counterintuitive, but it's as counterintuitive as TCP/IP was to WAN technologists. And the way I'd like you to consider it is whenever you join a protocol, Ethereum or Hyperledger or other thing, you can download the entire history, and you don't go back to the committee and get votes on it. You can see all the digital signatures and the hash links and everything else, and you can validate it on your own. Yet it's that next set of transactions or the edge of the blockchain is where you need the committee to decide. And what we did was took the property of the history and gave it to the transactions so that they could validate on their own without the need to sort of confer with the network. And that's really just the sort of processing that needs to happen. So what I see is that the consensus is exponential, the capacity throughput is limited. And so you can use these blockchains in small limited purpose use cases, but they're never going to become sort of the transaction protocol to the world. And as long as there's a third party involved, and although some networks have disintermediated the banks and the brokers, they've reintroduced oracles and notaries and validators, and those third parties either have to be indemnified or they have to have liability. But if they don't, anybody with fiduciary responsibilities is going to be very reluctant to go and work in those types of environments. So those are the kind of considerations. So I see scalability as a more holistic issue. And, and again, from a sort of process dynamics, the one thing I'd recommend to people and my background is that you always do the swim lane workflow just to see the dynamics, the control points, and the dependencies. And that if that isn't documented for your solution, not a schematic with boxes and arrows, but a true swim lane workflow, then it throws up what your issues are. And then the last thing you do in a product design is actually the accounting plan. How are you going to show the double entry accounting around these solutions? Because if you don't, you're setting yourself up to have some difficult discussions with your auditor. So anyway, that's a lot of points out there. It'll be interesting.
That's great. That's great. And what I really love about this is we've got really a variety of different perspectives on it. Really, you're coming from much more the accounting transaction perspective, and Tan's coming from more of the network perspective, and Venkat. Go ahead. Yep. Now we want to hear your perspective.
So I'm coming from, it's interesting to hear Dimitri and Paul, because my perspective is totally different in the sense that I'm not tied to Hyperledger Fabric versus the consensus protocol of BFT versus smart contract versus whatnot, or from a scalability perspective, off-chain versus on-chain versus the consensus mechanism of 1 versus 6, whatnot. What I'm more tied to is what type of feature function pattern that I choose that fits a particular business problem that I can solve. So for example, if we take Hyperledger Fabric as an example, which is what I've been using in the recent past, or Tendermint is another example that I've used that Cosmos is built on top of as well. they approach scalability factor in different or performance factor in different ways, and even among them, the design spectrum that you use, or design patterns that you use, could be the same or could be different. Case in point, the same design pattern I used in my patent was built on Tendermint, which on the healthcare space, I'm building the same design pattern on Hyperledger Fabric with similar performance considerations. The key to me from a performance perspective is doesn't matter what the volume of data is, or what type of data is, or where the data exists. I need to be able to pull and use the types of patterns in order to be able to render the actual data that the user is looking for with the right set of permissions, with the right set of authorizations, within the amount of time that is or performance that is enough to want the user to come back to using the solution, with the auditing capabilities and the single source of truth capabilities that the blockchain provides, and with the ability to one of the features of blockchain is this Turing completeness concept. So if you ask a purist blockchain person, you've got to have Turing completeness in all your transactions, whereas a business person who's trying to solve a business problem, this is where, like, what I'm trying to do is, yes, you need to have Turing completeness, but at the same time, blockchain becomes a building block, one of the building blocks, like TCP/IP, like other things, as long as the scalability and performance is met for the application that we're trying to build. My apologies, I literally, Jared called me last night to get on this, so not well prepared.
All right, I got one question, and then I know Mark Wasser's got a question. If anybody else has questions, by all means, just feel free to raise your hand or put it in the chat. So my question to each of you is, if you were going to, other than saying, well, use my solution because it's the best, if you were going to assess the scalability of a solution, right? What are some of the factors or characteristics that you would use, and potentially in addition to yours, what are some solutions that have some of those characteristics? So what are the characteristics or criteria you would use to assess scalability, and what are some solutions that potentially possess some or many of those characteristics? And it's open to anybody.
Well, I'll answer it from my perspective. Bitcoin mining has a finite capacity, so therefore, if that capacity is exceeded, you start getting backlogs. So that's a competition has a finite capacity. I mentioned earlier that consensus voting expands exponentially until it plateaus. The key thing is that that's those can be done. So it's not a matter of assessment. They can be looked at dynamically and how they behave. But the point is that generating transactions is linearly scalable. For the computing power to create a transaction is identical. So therefore, you can ramp up your computing power linearly, with the number of transactions need to be generated. The problem is in the validation, and that's where it's a nonlinear, an exponential computational problem. Therefore, the networks get slower as they get bigger. So the trick is not so much to measure the capacity, but to actually find a design that's linearly scalable based on the validation and the creation of the immutable, distributed ledger work. And that's the subtlety to the design.
So solutions like hash graph and some of those asynchronous methods, right? Would you say that a multi-threaded architecture is going to be significantly more scalable than, say, a single-threaded architecture?
Yes, in principle and in concept, yes. The problem with some of those solutions is that I talked about the fact that they still remain interdependent. And so there's a communication of, what they talk about, the virtual voting in Hashgraph of, gossiping about gossiping. So there's a lot of overlap and redundancy. And the latency there is between events created and events generated, events agreed. So absolutely, parallel processing on multi-threads is the key. The trick, though, is, like I said, like TCP/IP, is to remain independent yet interlinked.
Gotcha. Dimitri, any thoughts on that in terms of how you would assess
a lot of thoughts on that, of course, but let's just put it in simple terms. Sub-second consensus, sub-second finality, that's what I'm looking for. And in terms of the capacity or the performance of that, it really, then the answer is becoming complicated, because you don't have a single application probably that you want to perform one computation just for global set of people, right? So like you do have ERC token, for example, right, which can have a very large data set, very large amount of, I don't know, accounts who owns it, right? And you want to operate on this ledger of this token. And that's maybe like a one program that, if everyone would buy this ERC20 token, then you would have a very large program that you want to execute. And you want this program to execute fast. Is it possible in the design of single-threaded? No. I mean, it cannot be, right? Because otherwise you have to, as Paul just said, you'll have to have an exponentially fast computer engine who would repeat this process. But if you can design, and we, for example, we have this distributed token design where you can have I would say, I don't know, multi-threaded design of the same program, which would use the threaded design of the computer engine of the blockchain in this case, and will execute asynchronously and still remain, correct in execution. So there are ways to parallelize things. Some things maybe cannot be parallelized, we know that, but most of them can. And so, yeah, for me, this should be more or less unlimited in terms of the capacity to execute, because it should scale with the amount of computer power you just add to the network. Of course, it doesn't right now. And it doesn't because you have to find a consensus. But if you have an architecture that allows you to scale like that, just add if you need more computation, just add computer, just like that. Or add a set of computers. Like in our case, you would add 7. If you need just to scale, you just add 7 computers to the network and then 7 more computers. But remember, you should still be under 1 second, and you should still be mutable, meaning you should still be correct. And of course, it possesses a lot of questions, which I don't want to go into because that will become very complicated very, very quickly. Mm-hmm. Like how, for example, can these 7 computers which executes this be trusted? Is it possible to corrupt them or things like that? Yeah. But these questions actually have answer. Like there are solutions for that. But right now, there is no, like we see already glitches of this. Like we see we can build a chain under 1 second finality. We know that. Solana did that in one threaded. We can do that for simple computation like transactions, as Paul said. Can we do it with the complex computation? Not yet. Like the fastest we can go is what we are doing, and what Near is doing is about 2-3 seconds. Like like in terms of latency for execution of any arbitrary smart contract, right? But not yet under the second. Now, can we scale infinitely? Yes, we can scale infinitely. We already see that. We can build such an architecture. We'll just see some of these architectures. But then you pay with latency still right now. So you have to collapse this into one architecture, what we're trying to do. Actually.
So that's going to lead me to my next question, but I want to give Venkat a chance. Venkat, did you want to make a comment on how you would assess scalability?
Yeah, slightly differently. I think the traditional architectural methodologies around this still holds good to a blockchain solution. We kind of talk about horizontal and vertical scalability, and it's just that now you multiply the definition of horizontal vertical scalability for each and every node that's on the network, and corresponding assessment and solutions is now multiplied to each and every node. And all the definitions that Paul and Dimitri mentioned do make sense in terms of, but at the same time, you want to think in terms of horizontal and vertical scalability.
Got it.
Well, vertical's easier, but horizontal is the key. Yeah.
What about trade-offs? So, for example, if I want to scale, if I want my solution to scale, are there trade-offs that I have, security, or what are some of the
every trade-off you can think about. It will be trade-off on any kind of line you do. It just will be different trade-offs. But security, computation, like everything.
That's true.
I'd like to go back to a point that Dimitri made on that in terms of, I think what you're going to get to is the trilemma, which exists for some of the designs, but not all designs, whereas the CAP theorem applies to all things, but that's a bit more intellectual. But Dimitri made the point, if you've got a large transaction to generate, there's just no way you can process that quickly. But that's at the transaction generation. And this is what I like to separate. Like when people are agreeing to do something, there can be latency there. The problem is that if you've got 100 people doing, a transaction per second, you've now got 100 transactions per second arriving to be validated. And so the validation is the key process and how we can make that efficient. But if they're both linearly scalable, and I mean, the computation goes up with the same rate as the number of transactions, then the only thing you're really concerned about is the size of the transaction versus the processing speed of the router, and the distance in the network between the participants, in terms of getting the information out. But if you think about Bitcoin, if that's a kilobyte per transaction, if the transaction generation is linearly scalable and a router can do a gigabyte per second, that's 1 million transactions per second. You halve it because you've got to send and receive, but that's your sort of peak capacity with that kilobyte transaction with a gigabyte per second router. So those are the potential speeds that we have available to us at a peak if we've got linearly scalable generation and validation.
Got it.
I have a slide for that. Wait a second. Here.
All right.
Yeah, that's one.
I can be your agent if you want to.
Sounds great. Listen, I want to give the audience a chance to ask some questions. I know Mark Wasser's got a question. Mark, if you're ready, you want to unmute yourself and ask?
Sure, absolutely. I'd like to go up to a much higher level because we sort of seem like we're down in the weeds here. I've also heard a number of statements about things that are or are not possible. As far as I understand, scalability really depends most thoroughly on two things, with a third thing that's minorly important. The first thing, of course, is the consensus method. Proof of work really doesn't scale well as you have larger cliques. Proof of stake tends to scale much better, but there are also similar consensus methods. For instance, distributed proof of stake, unless someone's comment is fully capable of sub 1 second transactions. really that is limited by the speed of the machine, which again has a very minor influence on scalability. But quite honestly, the driving forces are really your consensus method and also how you partition your networks. And I'll go into that in a second. My one other comment on consensus is that there are indeed consensus methods that have immediate finality. They aren't like Bitcoin, where you have to wait an hour in order to get 6 confirmations, or Ethereum, where who knows how long it's going to take because gas is slowing things down. So you use one of those immediate finality consensus algorithms, and I don't think that you're going to have that much of a problem with your financial transactions.
Ron, sorry, Mark, did you have another point?
Yeah, getting to partitioning, there are really 3 different ways in which you can do partitioning, or at least 3 different ways. One of them is, of course, sharding, which Ethereum is trying to move to. I know that's why Ton claims infinite scalability, which I always have a problem with infinities. Another choice, of course, is gateways and other blockchains. For instance, Bitcoin, has its payment gateways. Ethereum has Plasma, and there are all sorts of ways in which you can partition different jobs onto either subchains or parallel chains. And honestly, it's the same way with what the GBA is doing with the GBBP. If you can isolate certain types of transactions so that they're primarily run on one subsection of the set of blockchains, because that's really what, for the most part, partitioning is, you tend to get rid of a lot of your scalability problems. Quite honestly, having a global Ethereum, for example, is sort of nonsensical. I would also argue the same thing about Ton. What is the advantage of tying everything together at the topmost level rather than just having, some consensus some consensus about how you route things? And I think Paul would agree with the vast majority of what I'm saying. So I'd love to hear from him first.
Okay. Well, you're going to be disappointed then. No, sorry. So consensus is exponentially increasing. And what I try and say is, look, as much as mining proves there's an alternative to consensus, and consensus proves there's an alternative to mining, and proof of stake has its own little life on the sidelines, that means there's alternatives. But I was talking about earlier, the theory on what they call conflict-free replicated data types is actually known as consistency without consensus. So there is a way to actually generate consensus across a network, or consistency, without actually having everyone to have a vote on it. And that's really the sort of the power that's available. So I'll make that point. Anything that involves consensus in any form increases exponentially with time. And the other side of it is when you talk about partitioning, I mentioned you need to be parallel, process, independent but interlinked. And that's where, and I go to the analogy just to keep it at a high level for everybody, LAN and WAN technology was a central controller, meaning everyone went through the same central point. It's like the FedEx hub and spoke process. And I even remember President Bush Sr. saying, we need an information superhighway, because everyone thought there was going to be this massive global exchange that would connect everybody. And then suddenly we woke up to the DARPA thing that had created in the 70s, which was, this thing called the Internet Protocol. And that works by allowing everyone to put their data in packets, and they all share in the processing and passing along of data until it finds itself to its right home, and then it gets reconstructed. But because everybody's independently processing but remaining interlinked because of the packet structure, you don't need that central controller. And there's a sort of similar idea in these properties, which I told you about, conflict replicated data type. So that's where the answer lies.
Fascinating. Ron, did you want to make a comment as well? I'm trying to let folks that are active in the chat feel free to participate in this
Sure.
global
I'd be,
discussion.
I'd be happy to, and I sort of put it in the chat, and I know, I mean no ill will, but my position is very simple. I think that permission environments are where totalitarian governments thrive quite well, as do corporations who've hijacked the internet, as do banks who've hijacked finance, and calling them institutions of trust, I think today would make a lot of people grin at the very least. So for me, a decentralized blockchain run by a community exclusively. So imagine Bitcoin, but with the ability to scale and the ability to have business logic and work at a speed of a MasterCard or a Visa, is exactly the answer that's needed, because it gives the I don't want to sound cliche or anything like that, but it gives the power back to the people, and that's really just my point.
I think Ron actually mentions the discussion that currently is ongoing in the chat, because like maybe some people are not didn't realize
there's more going on in the chat.
There's a parallel discussion going on in the chat.
No, which is absolutely
yeah.
great. I mean, again, the purpose, the reason why we do these things is to get people together. And if you're having a conversation in the chat or live, and then hopefully when we're all done, I'm going to ask everybody to put their contact information in the chat if they want, and they can scrape it. We'll make all this available, and hopefully people make great connections. But sorry that I think Dimitri didn't want to interrupt.
No, it's fine, totally. I'm just saying, in terms of central, not central, yeah, we can comment later. But I want to come back to Mark's point, because I think he also didn't finish, at least, I don't know, about the I like Ethereum as well, Mark. We're just in disagreement that's the answer, because well, I had that slide before, actually. If you want, I'm talking about complicated calculations. I think that when you say Ethereum is holding just fine, I don't know which Ethereum holding just fine, because as
I wasn't talking about Ethereum.
Okay. Okay, I was then misunderstood something. So yeah, but yeah, mostly I think it's valid comments. Again, I just think that we will arrive very soon, sooner than people realize. We will arrive at the blockchains architectures. Will be several of them, which will perform just as what I said before, like sub-second. And in terms of computation, what we didn't mention, I think, and we should mention that, is there is also a computing power increase all the time. We remember that, right? And not only computing power, but also the storage. Like the general price per storage, per megabyte of storage, and per computing, per I don't know, flop, whatever you call the computing power measurement, is decreasing constantly. There is a line it's still decreasing, and it's constantly decreasing. So I believe that in the that should continue for at least 5 to 10 years at least, maybe more, because I'm sure we will find ways to continue that. And if you take that into account, then this kind of architectures, the new ones for the blockchains, they will scale further just by adding computing powers. What we cannot do is we cannot make the packet travel faster than the speed of light. That's we won't be able to do.
And no, there's action at a distance in quantum computing. So.
Well, quantum computing is fine, but
Right. No, I'm talking about the action at distance, where you get two particles to communicate instantaneously.
Right. You need to also. I was talking about particularly about packet.
Quantum entanglement.
Please make a quantum computer transmit a packet, and then we will talk.
There we go. No, believe me, I'm
So I think you meant quantum entanglement is the technical term.
So let me bring Venkat in real quick.
There's a couple of points. Sorry, go ahead, Jared.
Well, go ahead, make your points, and then I'll ask you a question.
Yeah, so a couple of points I wanted to make was back to Mark's comment. Right, I truly believe that we need to choose the right consensus mechanism to be scalable in different types of the problem. And case in point, I chose the Byzantine fault-tolerant consensus mechanism for the military intelligence solutions that we built on top of for exchanging intelligence data across agencies, primarily because you're talking about streams and streams and volumes of data. It could be streams, it could be video data, it could be audio data, it could be consolidation of an AI results of a data set. Doesn't matter. You've got to be able to move this volumes of data in split-second time and seconds of time. So I chose the consensus mechanism for that, the BFT type of consensus mechanism for that same purpose, because I need to be able to move these volumes of data. Whereas on the healthcare space, it's a little bit more of a nuanced space and a little bit more difficult to handle. Even though I do have a volume of data, I don't have the same amount of speed of movement. I don't need the same amount of speed of movement like the volume of data that I'm talking about in the intelligence space. So I used more of a smart contract based consensus mechanism where I'm building a smart contract. So case in point that I'm trying to make is that your business problem, to an essence, has to drive what consensus mechanism you can use, and Dimitri's and Paul's of the world will be able to provide us the underlying architecture and the technology to choose whatever consensus mechanism we can use to the scalability and the performance that we want and we need for the problem. There's a lot of discussion. Second point I wanted to make was there's a lot of discussion going on in the chat about private sorry, permission versus permissionless blockchain. So I want to set the record straight a little bit. This is I want to share. I'm going to share my screen. Right. This is kind of what I go in when I talk about blockchain. There are two concepts that we need to think have in mind. One is permission versus permissionless, and the other one is private versus public. There are two different concepts in our mind, and there can really be uses for both these concepts and interface of both these concepts in the blockchain world. In majority of the corporations do use permissioned private, which means the reading from the blockchain and writing to the blockchain is controlled and managed. It doesn't have to be by a central authority, but even that can also be distributed, and everybody agrees on the on-ramping and off-ramping of, so there can be a consensus built in to the on-ramping and off-ramping of solution users as well. The exact opposite of it is the Bitcoins and the Ethers and the Ethereums of the world, where the readers and writers can be anybody, as long as the calculations or the mathematical formula, the proof of stake and the proof of work they can prove that they did the work and they have the stake, right? So it's more of that type of an approach, consensus type of an approach, which is public, and only certain people can prove that they have the ability to participate. The flip side is a little bit in between both, right? There is a permissionless public where, permissioned public, which is, for example, I want to be able to give access to my university degree to anybody who wants to know that immutably know that I have my university degree, I have a master's, right? So my master's degree is generally publicly available, but only those people, the universities who have the authority to give that degree, can write data into that blockchain. So that's where I go into permissioned public blockchain, and the less private. We're in a great space for a permissionless private great time for me. Every US citizen has to be able to vote. but only those people who have the authority to look at the results can get in and see the results. So I just want to make sure that we give a clear distinction, which is why I keep talking about the fact that we need to choose the consensus mechanism that we need to use for the problem statement in picture. Thanks, Jared.
Sure.
I want to comment on that because we didn't really. I didn't want to go into the permissionless permissioned. Now as we started, yeah, I have a quite polar view on that. Guys, can you mute please whoever not speaking or speak up? I don't know.
Sure, I'll get everybody. I'll mute everybody. They can unmute themselves.
Yeah, it's fine. It's fine. So the basic, I disagree with that slide. I totally disagree with that slide, and I think it's a little bit reminding me of. Still have some noise. It reminded me of what Paul said before, like when we remember when we had LANs, local area networks in the beginning, like before the internet, where we had computer networks inside, inside this private computer networks. And I were walking between like Sun Microsystem booth in, I don't know, 1992, something like that. And they were talking about this LANs, like everything is LAN, like it will be LANs and it will be WANs, like they will be interconnected and they will all be, happy, live happy, because we don't want anyone to come to our network, it's unsecure, blah, blah, blah. And it was before firewall, obviously, and stuff like that. And then internet came. And then very quickly you discover that if you're not connected to the internet with your all glorious LAN, you no longer can perform really in terms of like you cannot run your business anymore. And then of course the technology came many technologies came who actually protected your private data inside the public cloud and stuff like that. So, and I think exactly what will happen here is more or less, and what we're witnessing now with these permissioned blockchains is exactly what we had in the beginning of the internet or before. Like, why do you think university need to have a private blockchain with public access to only them be able to push some certificate? They can perfectly do that on public blockchain, being there, setting up their authority and issuing their tokens, and that will be perfectly fine. Now, if you have a corporation that you say, okay, there is some sensitive data which I don't want to reveal, I don't want to see the people to see my transactions on the public blockchain. Well, there are solutions for that. They call ZKP. And you can now, have this data completely obfuscated and still correct. And you can prove what you did right to the people, organizations you wanted to prove it, and hide it from everyone else. So I really don't see a reason to run many private blockchains. I can think about the reason why we want to have many public blockchains, but that's entirely different. I don't believe that we will have one public blockchain which will rule them all. I totally agree with you on that. But in terms of private blockchains, they should die as quickly as possible.
Can I ask a real quick question that we might clarify the whole thing? Then can you give us a great example of usage of a private blockchain that could not be replaced by database?
Yeah, I can give you an example actually. Yeah, or
go ahead, Dimitri.
I can understand this logic. Why? Because you have a logistic chain, for example, which runs between several companies. None of them are trusting each other, and you want to have between them some trust on some transactions, logistics data that they pass to each other. And the good solution for that, I think that's why IBM is building that with Merck or whatever. And they have this solution where logistic carriers are on the same blockchain passing data, and they have each like holding validator. So they kind of agree that they cannot collude, right? Or at least it's an assumption that they cannot collude. Now that's why they say, Marina, why they need it. Of course, the other point that I'm making.
Assumption word in your statement. I still would love to hear a great example from Venkat where I would not be able to replace it with a database.
You cannot replace that with a database. I mean, if
Well,
you replace it with
well,
a database, you
Dim-
will lose this
Dimitri,
you need to build the trust.
Dimitri, let me give you some insights as I understand it with regard to that IBM the Tradewin project, along with the other IBM project, which is a Walmart one, right? The food safety. So my understanding is that the Hyperledger project through Walmart was relatively a success, right? And it was a success because all of the vendors under Walmart essentially are on the same level footing, right? Walmart essentially is the folks that administer the blockchain, right? And all of the vendors under Walmart essentially are equal. But the problem with the Maersk blockchain Hyperledger project was Maersk was an admin of the blockchain, yet at the same time, they were a competitor. And so that the other members of that blockchain didn't necessarily trust Maersk to manage the blockchain. It essentially put too much power in the hands of one of the competitors. And so going back to Marina's point, in the Walmart example, I would imagine that a database would have been fine for that. In the Maersk case, the blockchain actually wasn't that, from what I understand, maybe anybody else on the call has additional information, that concept didn't really work very well because the players, the admin and the players were not equal, right? And so anyway, so I want to let Venkat, well, Dimitri, you can respond to that if you want to, but I also want to give Venkat a chance.
No, sure, absolutely.
So
Venkat.
the example that I'm and there's always argument between single database and blockchain network, right? So the example that I tend to give, there's two examples. Both the examples that I have is in the military intelligence space. I can guarantee you that United States and Canada is not going to put their intelligence that they have share into a single database to be able to share, to be shared. That then we start getting into who controls the database, who has access to that database, and more even more simpler point, which is or a subtle point, which is the database became unwieldy, which is why the military was looking at a solution and looking into blockchain. The database becomes, you're talking about petabytes of data. It just simply become unimaginably unwieldy when they started collecting all the data into a single database. So that's one problem statement. Yes,
just the terabytes of data is much cheaper to keep in database than to keep on a blockchain.
We are not keeping. So that is where you start getting into scalability, optimal solutions using a blockchain. I never said that I kept all the data into the blockchain using my solution. I never said that. I just used the blockchain. The data stays where the data owner has the data, and that owner controls the data. I'm just enabling the authorization.
I don't see why you cannot solve it as multi-sig.
I'm sorry?
I don't see why you cannot solve it with multi-sig solutions.
MPC kind of stuff, right? You're talking about.
Yeah, she said she doesn't know why you couldn't solve that with.
I know what she said. MPC, you mean, Marina, right? Multi-party computation.
No.
Yeah, you of course you can do that, but very limited, like because it's only it becomes very complex to build an MPC solution for arbitrary kind of settings. Like to administer everything for dozens of thousands of people with the MPC, I think it's practically impossible. The blockchain gives you this, so like it out of the box. Yeah, again, Marina, I'm totally on your side. I don't think it should be a private blockchain corporation, as I said before. And by the way, the databases, cluster databases, they're, except for they don't produce blocks. Other than that, they run by consensus algorithm, right? So in that respect, if you talk about multi-cluster,
I mean, at the end of the day, it has to have a consensus mechanism source.
Exactly, Paxos or whatever, right?
Listen,
disagree.
I'd like
I
to.
don't think
I'd like
this
to.
is the thing. Consensus is the thing that's weighing everything down. You don't need consensus to get consistency.
Well, wait. You have a consensus. You have a perfect consensus inside the database cluster.
Except the consensus is very slow.
No, that's why that's why we want to avoid it completely.
Yeah. That's why we don't want to do it like that. Yeah.
All right, guys. Let me do two things real quick. Paul, I want to come back to the consistent versus consensus because I think that's a fascinating thing, and I'd like to explain that a little bit more. But before you do, Venkat, the question that I wanted to ask you is, knowing what you know about government acquisitions and government use of technology and the paradigm, right?
Mm-hmm.
Do you see a place where governments could rely on a scalable solution, an enterprise-wide and a government solution that is decentralized, not just distributed, but really is decentralized? Can you imagine that any time in the near future? And if you can you elaborate? And then after that, Paul, if you wouldn't mind kind of walking through the concept between consensus and consistent again. I think it's a fascinating concept. I'd like you to peel the onion back on that.
So I can't imagine any time in the near future, at least on the federal government space. In the state governments and outside the US, yes, potentially in the near future. And there's a lot of work going on, especially in Southeast Asian countries on the financial side. They have started talking about a multi-country trade network as an example. In the US side and to an extent Canadian side, state governments might take over, but federal government, I can't imagine them needing so need is one thing. I can't imagine them going to that, even though they may have a need.
I think that we're advocating that if folks want to get decentralized systems into a government space, that they should really start at state and local or smaller countries, smaller jurisdictions that may not have the organic infrastructure to maintain large enterprise systems, but could benefit from decentralized systems. And then eventually that does creep into the higher levels of government. Would you agree with that?
Right. Yes. Correct. And that's one of the paths I'm taking, especially with grants, right? And is to start at the even below the state level, at the NGO level, where the grants are being used to track and ensure compliance to the grants, and then kind of creep up and build to the state. And then to the federal government. There's one area that I think the federal government can see a lot of value is what the Sovereign Project and the Hyperledger Indy project was trying to solve, which is the citizen identity aspect. I think that has some value to it. It's probably the first place.
As a decentralized solution?
As a decentralized solution, correct.
Wow.
That's where I see value, immediate value. But again, I go back to, I don't think the federal government should start at the federal government level. We should start at lower level.
Right. Paul, well, actually, before you answer the question, anybody else on the call want to make any comment on that has any knowledge or insight in terms of government use of decentralized systems in short term? All right.
Say something. When you say we need to start, we already started in Estonia, right?
Yes.
Well, I think even in Estonia, though, that's a permissioned blockchain, right? I mean, I think Estonia had
that's what you advocate in starting with, right?
So I would argue whether Estonia is a blockchain or not. That's a different discussion.
I'm speaking from Latvia, so I can just tell you that they have this smart contracts in the ID that I can presumably do many things with them with the electronic signature. And actually in Estonia, they use electronic signature for voting and stuff like that, which is nice. But in Latvia, I'm literally telling you, nobody uses that. Like not a single person that I aware of is using this, simply because it's just not. When the government want to do something, does something, in most of the cases, they do it so badly that, like, on the execution level, we should not allow them to actually do anything, I think. And the problem is that they will stop everything from happening simply because they don't want to get fired. And I think half of them will lose their job if they would, go to the blockchain, right?
Yeah.
Anyway, sorry for commenting.
Yeah. No. Listen. I think you're right, and this is, from the Government Blockchain Association's perspective, this is really our challenge, right? Is recognizing, number one, you have a paradigm that's very resistant to this, right? You have an education gap. At the same time, the world is moving fast, right? If you look at the cryptocurrency economy, it's now the 7th largest economy in the world. And we need to help governments understand that whether you go or not, the world is going to move in this direction. And so listen, I want to put a quick plug in for the event that we're doing in May called Government Blockchain Week, with the feature event called The Future of Money Governs the Law. For those of you who don't know about it, if you go to gbaglobal.org, there's a link on the main page. One of the days that we have on Wednesday, we have 2 events going on Wednesday. One of them is legal law enforcement and cybersecurity, and the other event that day is money, banking, and cryptocurrency. And so we're inviting financial leaders from around the world. We've invited the Office of the Comptroller of the Currency, one of the members of one of the commissioners from the SEC, the Union of Arab Banks. Gosh, I mean, you talk to a lot of these folks, they just don't, especially in the banking space, they just don't understand this world. So we're going to bring them together for a forum for discussion. Then we're going to take the top leaders to the Embassy of Bahrain for a private fintech roundtable. We've got about 25 or 30 leaders there. And then after that, we have about 600 people that are going to go to the rooftop lounge, the rooftop of the International Spy Museum for an event that night. Then the following 2 days will be at the United States Capitol in the Congressional Auditorium. So that's gonna, if you go to the main page, you'll find that on the GBA homepage.
When you're talking about SEC Commissioner, you're talking about Hester, right?
Hester, right? Hester Pierce.
Okay, just want to make sure. Can you post the link in a chat?
Sure, I can. Yeah, if you go to gbaglobal.org, it's on the homepage. In fact, here, let me share my screen real quick. It's going to be quite an event. In fact, yep. So if you go to gbaglobal.org and hit the homepage, it comes up. It's right here. World-class speakers during Government Blockchain Week. And if you hit the world-class speakers, speakers are awesome. So Don Tapscott is he's a global leader in essentially in business. Scott Sternetta is one of the folks that invented the blockchain in 1991. So he and his research partner actually put the first blockchain into operation. And Satoshi Nakamoto's white paper lists Scott's work in 3 of the 8 references. And then you can see we've got folks from, Alabama Securities Commission, the Republic of Kazakhstan, the Australian Trade Commission, the Austrian Institute of Technology. This guy, Dr. Ross King, he's with the Interpol project Titanium. This was a 15-country project, basically to understand cryptocurrency to help law enforcement be able to do their thing. Blockchain Intelligence Group. We got Romania, California. We got these guys there from CGI. I don't know. You might have heard of them. But Colorado, Virginia, Croatia. We've got one of the founders of Dash, the compliance officer from Crypto.com. So it's really going to be just a phenomenal who's who of blockchain and cryptocurrency leaders from around the world. Government of India, just all over the place. Slovenia, Rhode Island, just all kinds of stuff. And we're still in the process of getting speakers. And then the full schedule. I'll show you this. So the full schedule is Monday, we're doing blockchain use for state and local governance. We got a network reception at the British Embassy. Then on Tuesday, we have two main events. We've got the Blockchain Innovation and Economic Growth Symposium and a pitch competition. That's likely going to be at the United States Department of Commerce. And then we're also doing blockchain and international trade and development. That'll be at the British Embassy. And then we'll have a reception that evening. And then Wednesday, I told you we have the legal law enforcement cybersecurity forum, and then the other events, money, banking, cryptocurrency, then the roundtable, and then the kryptonite evening reception. And then Thursday and Friday will be at the United States Capitol. These are pictures from our last event there. It's about 450 people. We'll have an art show. We'll have an after party. There'll be virtual reality, live bands. We'll do the annual achievement awards. It's a pretty incredible event. And that's all going to be May 17th through the 22nd, in person, live. All right. So, Paul, tell us about that whole concept of consistency versus consensus, because you talked about it briefly.
Consistency without consensus.
Right.
The key thing to recognize is that and I'll try and do this in as simple example as possible. If you imagine a series of nodes and each node creates 10 transactions, then they have to sign, their transactions, but they have to vote on the other node's transactions and then count everybody else's. Yeah. So if you have 3 nodes, you sign your 10, but you've got to vote on 20 from the other 2 nodes. But there's 2 nodes that also voted on 20, so you have 2 times 20, which is 40. Go to 4 nodes, and you have 3 times 30, which is now 90 votes to count. Go to 5 nodes, you've got 4 times 40, 160. Then 5 times 50, 250. And you can see it exponentially. The amount of votes that have to be counted goes up exponentially as the network expands. This is the horizontal scaling that Venkat mentioned the other day. So consensus in any form expands exponentially and gets slower with greater participation, so it works in limited use cases, but it's not going to be the sort of the grand solution to everybody, as well as the fact that you've got to transmit those votes, receive them, count them, and then decide that you've got a good enough number. So that whole latency thing kicks in as well. So that's where, if you can get consistency without consensus, you've obviously gone to a linearly scalable and very high capacity throughput and low latency processing. And we achieved it with our design, but then I found this research that sort of kind of backed it up. And where it originated from was, I believe this researcher was working with Google. If you imagine, Google maps the internet in its various regions, and then the regions communicate their internet mapping to the other regions. Well, how do the other regions know that they're consistent, that they got all the information, that there's no conflicting information? And so this theory was, if the data included certain properties, that you would be, and there's a concept, if you just blast things across the network, there's a concept of eventual consistency, which is eventually everyone will get all the information. The problem is you have no idea whether you're in conflict or anything. With these properties, it was claimed they had strong eventual consistency, which means they would definitely get consistent. They just wouldn't know when, but they would not have any conflicts. And if you think about a blockchain, if I gave you the Bitcoin blockchain, you can reconstruct it. And if I told you there's 555,000 blocks today and you have 4,999, you know you're missing one. So there's your completeness. So what we were able to do was create a construct such that we had consistency without consensus and completeness as well. So each of the nodes are processing their transactions and sending it to the network, and the transactions are self-synchronizing. So that's the strong eventual consistency, was the concept of consistency without having to synchronize, which then obviates the need for voting. And I'd make a point to this, because if you can get to near real-time settlement, and you've got that level of control, and this goes back to the controls that banks and brokers use all day long. People want to forget about them, but they've got some pretty good ideas around control, that you can actually stop the double spend at inception. And my argument with a lot of the solutions is that they claim to solve the double spend, but they actually don't. And they include Bitcoin. The reason why is because the double spend is allowed to happen, but through the mining process or the voting, one or other of those transactions is rejected, or possibly the network rejects both. So that's not really stopping the double spend, it's arbitrarily selecting either or neither. And that's not because most double spends are not people trying to trick Bob while they're paying Charlie, all right? It's not that. It's the fact that you swipe your debit card twice by accident, or you went to write a check. Now, the problem is if I paid Alice by accident and I meant to pay Bob, I want the Bob payment to go through. But the current networks would actually arbitrarily pick Alice or Bob or neither. And what we're saying is that you should be wary of your payment and be told that at the point. So at the point where you go to see Bob payment, you would actually know you've made a mistake and you can rectify it. But so there is this research that backs up the idea of consistency without consensus. But how we've made it work across the network is part of our secret sauce.
Got it. Listen, we are closing in the last 15 minutes, so I want to give everybody an opportunity to connect. So Venkat, I'm going to go back. So if people are interested in the work that you're doing, is there any way that they can connect with you, and what sorts of things are you looking for? And then Paul, I'll go to you, and then Dimitri to you.
Why is it that you always ask me the question first?
I can ask Dimitri. I'll ask Dimitri first. Okay, go ahead.
I'm kidding.
Can you post either your Signal or Telegram, please?
Yeah.
We're gonna ask everybody to post their contact information in the chat, and again, I will. If you come back to this event on the GBA site sometime later today, I'll have a link to this entire conversation and all the chat as well. So we'll make all that information available. It generally takes about 20 minutes for Zoom to process everything, and then we'll just put a link to it on the event page.
Yeah, so I'm posting it on my on the chat page. Give me a minute, but I'll be happy to connect. LinkedIn, my email address, Twitter.
And the main thing really is for folks that have an interest or potential opportunities to connect in the area of healthcare. Is that right?
Actually, in general, blockchain applications that solve business problems is where I go with. Government and healthcare would be my first choice.
Right, and Venkat is the practice lead. You're the director of the blockchain practice. Is that your role there?
I am my title is director, but my role is practice lead for blockchain for US.
Gotcha. So if you're interested in connecting with CGI and their blockchain practice, then Venkat is the guy to do that. Paul, if people want to connect with you, what's sort of the great sort of synergy there that they can connect?
They can find me on LinkedIn, and by all means follow me. You can see a link to if you look at my posts, or we also have a I'm just posting a thing page for our company L4S Corporation. So I'm just posting that now.
When are you gonna be putting a product out soon, or what's your sort of release schedule?
The goal is probably third quarter next year if we raise the funding we're expecting. So we are obviously interested in any Series A investors or target clients for use cases. If you're not in that initial run for our production, it would be, you'd be lined up early as soon as we're launched. But the idea of the design as well is it's both process, asset, and life cycle agnostic. So the assets and the counting are configurable.
Excellent. And then Dimitri, Ron, would tell them how people can connect with you guys and what sorts of things you're looking for.
I have posted my Telegram on the. You can connect me there.
I posted my Telegram. I'll post my LinkedIn as well in just a moment.
Gotcha. And then what are you guys looking for? Like what would you like people to connect with if they'd like to develop on the TON platform, if they'd like to use the TON platform?
Well, Freeton is completely decentralized kind of community-driven project. So you are all welcome to participate. And we have like a structure where we have sub-governances, and you can create your own if you want on the platform. And there are many sub-communities, like can be geographical or can be subject-based. There are developers communities, several. There are like, I don't know, some marketing communities, like stickers community, I don't know, whatever you want. And you can participate. Yeah, you can participate, and we're welcome every participation. There you can actually like propose your own sub-governance or community to create it. You can actually, we can like a community, if you propose some plan, the community will allocate some tokens to you for you to run contests for your communities, and everyone is welcomed.
Excellent.
It's a partition governance essentially. So basically it's small groups of 50 to 100, in some cases 400 people that are basically executing certain tasks. Like one group is doing public relations, another group is doing marketing, another group is doing website design, another one is doing a wiki, and so on and so forth. I mean, there's dozens of them. And the second thing is, of course, partnerships, which are made through proposals to the community that votes on them and then brings partners in that bring users. So that and contests are the two meritocratic based principles that the blockchain operates on and grows. Thank you.
And you bet. Jovan, you are next on the plan. One last thing, Ron, how many folks do you have in your community? It's a pretty big number.
Oh God, I'm not going to get it. It's I think it's pushing 30,000 now. Isn't that about right? Yeah.
It's a pretty big community. Jovan, would you like to put a plug in for GBA? Introduce yourself and put a plug in.
Ladies and gentlemen, my name is Jovan Marjanovic, and I help Jar at the GBA. I would just want to remind you that if you like this panel discussion, that we are a member-funded organization. So if you're not already a member of GBA, please reach out. If you are members, you may be members as individuals or as corporations. For the benefits, if you'd like to learn more about the corporate membership, again, please reach out, and Gerard and I will be happy to follow up. Also, our event that Gerard was talking about offers sponsorship opportunities, very interesting sponsorship opportunities. So have a look at that as well.
Yeah, and if you're not a member of GBA, I just don't know how you sleep at night. I just really don't.
Yeah.
So, excellent. Good. Well, listen,
my contact info is in the chat box as well.
Right. So I want to give an opportunity to anybody else on the call if they'd like to plug a project that they're doing or anything that they'd like to get involved. Just raise your hand. I'll acknowledge you. And then, and I'd also like to put a plug in for the Boston Blockchain Association. Lily, if you don't mind, put a link into your meetup group, right? And Lily, what's the next event? You got another event that you guys have you're put on the calendar here pretty soon, right?
Yeah. So we have an event on next Thursday, 29th, 6:30 p.m. Eastern time. That's usually when our event held. So I will share my the LinkedIn profile page and also the BBA website, the website and the LinkedIn page. Stay tuned.
Sure. And then just as a public service announcement, I'm speaking for Don Tapscott's organization, the blockchain what is this thing called? BRI, right? Blockchain Research Institute on the 29th at 10 a.m. So anybody else want to promote or plug what they're doing before we drop everybody off?
I just want to make a general statement that we're not going to go very far with anything on a blockchain until we seriously start developing middleware tools. Because right now we dig in the ground with bare hands. We gotta get developed shovels.
Yeah, I think that's coming. I think people are working on that. We're in a much better state of that than this year than we were 2 years ago. But I completely agree with you, Marina.
But can you give me an example of a sync tool? Because I haven't noted anything.
What tools are you talking about?
I think Symbichain is a great tool. Symbichain's a great development tool. It's a multi-blockchain development tool.
That's an
SIMBA.
environment. That's not a tool. I'm talking about, a better smart contract languages.
Yeah, I can comment on that. I got it. Yeah, we have in Freeton,
easier formally verifying things. I mean, you name it. I'm seriously telling you, right now we dig into the ground with bare hands.
Yeah. Well, I can comment what we're doing in Freeton for that. So we have created two compilers, one Solidity, another is LLVM-based C and C++ Clunk support. So in Ton Labs, we're constantly building like these tools all the time and improving them. We will also planning to add some other languages, maybe like Rust, stuff like that. In terms of formal verification, we are, I think, the only blockchain who is doing formal verification for all the key smart contracts. We're doing that in Coq. We have a special team, Provenda it's called, out of St. Petersburg, who is working exclusively with Freeton to do the formal verification of all the basic and smart contracts, also accepting obviously from the community if you want, but they're quite busy. And during this, they are obviously improving tool chain for that. So they are doing, EDSL on top of Coq to make it easier. They did Ton virtual machine implementation on Coq, so as part of the formal verification process. So this, I think it's coming. Yeah, don't know about others, but yeah.
Can I ask why you chose Rust instead of WebAssembly?
Because, well, we didn't choose Rust instead of WebAssembly. It's just that Ton has its own virtual machine and it's not WebAssembly. And the reason why, it's because it's more compact, and that's important. There are also some other properties on Ton virtual machine. So like the WebAssembly was not supposed to be run on blockchain, right? It's for completely different purpose created. And as such, we don't believe, we totally agree with Nikolai Durov. It's not entirely built for and good for blockchain. And once we have this virtual machine, we had to create tooling around that, like in WebAssembly. And actually, we are the only other participant in LLVM community who is actively promoting the stack-based LLVM kind of frameworks. So, and we actually had a participate in LLVM a year ago, before the COVID, obviously, gathering, and we had a paper and presentation that we did in the LLVM community about that, and you can look that up if you want.
Rust was also not developed for the blockchain.
Hey, Marina, I'm going to have to wrap us up here in just a couple minutes ago. Was there somebody else who said something real quick? Yeah, Paul.
Jared, just quickly, I wanted to say one of the issues I brought up at the beginning was the lack of double entry accounting in a lot of these solutions, and this is key for anything that's going to call itself a ledger. And it's certainly a topic, and also the idea of workflowing the use cases. And that's an area where, people have often come to us to sort of say, how do we decipher these things? And that's a key aspect that most people have forgotten. And it's actually going to be a problem in the future if it's not really addressed.
Yeah, right. Absolutely. All right. Well, listen, I'd like to thank everybody for joining. We're going to be doing this again. I just realized as we were talking that I need to schedule one of these on the topic of security, because we did scalability today. So maybe in December or January, we'll also do security. If any of you have any ideas about subjects that you'd like us to cover, by all means, please feel free to reach out. I'll put my email address in the chat. It's gerard.dache@gbaglobal.org. Boom. And like I said, I'm going to leave this open for a little bit if you want to scrape the chat. If you'd like to get the full video and the chat later today.
Yes, please. I was going to ask that.
No problem. Yeah, but so just go back to the event page on the GBA site. and right now it has a Zoom link, but that will be replaced by a Dropbox link, which will give you to all the chat, the audio and the video for this meeting. And thank you guys very much, and I'm really grateful that you all showed up.
Thank you.
Thank you so
Gerard.
much. Thank
Great
you very
meeting.
much.
Thank you.
It was
Thank you,
very
guys.
interesting. Very interesting.